Hey, I'm not looking forward to this video, but resilience activated. Hello, welcome. We are looking at the department's November 2023 paper 2, question 6. I am not in the mood for trig graphs, but here we are. Let's do it. Question 6. In the diagram, the graphs of f of x, the microwave might go tweet at some point. I'm cooking. Yeah, okay. In the diagram, the graphs of f of x is equal to 2 sine 2x. Okay, so that's a sine graph whose period is 180 degrees instead of the usual 360, and the amplitude has also changed from 1 to 2. So we can see here that our graph goes up to 2 and then down to -2, right, as labeled, and we have one full wave within 180 degrees. Okay, so that's what's going on with the sine graph. And then we have g of x is equal to negative cos x plus 45. So that's a cos graph that's been reflected in the x-axis, so that we can tell from the negative sign over there. And then the x plus 45 is indicating to us that, okay, relative to our normal cos graph, this is now cos graph that has moved 45 units to the left. Everything you own in the box to the left, in my closet. Okay, right? So what we will see, for example, is that, okay, we know that, okay, first of all, the normal cos graph would go right, and would dip there at 180. And then if you were to reflect in the x-axis, then that trough would now become a peak at 180, sorry. But now that peak has moved 45 degrees to the left to 135 degrees. So yeah, that is what is up. Drawn for the interval x is between 0 and 180. Okay, then we're told that there is a point A whose coordinates are 105 and -1, and it lies on F. Right. Write down the period of F. So that's our sine graph, and we've already discussed that, okay, the normal sine graph is a period of 360. But now this sine graph is going twice as quickly, so it will repeat itself every 180 degrees instead. Okay. The next question says, determine the range of G, which is the cos graph, in the given interval. Ooh, interesting question. Haha. Because, so if they just said determine the range of G and J in general, that would just be from -1 up until 1, right? But specifically looking, better, don't give up on me. Specifically looking in this interval, okay, we definitely know that we have a peak. It's moved 45 degrees earlier, right? So there is a peak at 135 degrees. The range peaks at 1. Where is it its lowest is going to be here, right? Because normally, like we said, our normal cos graph, if we just look at y is equal to cos x, it would have had a high point here, and then it goes down. Well, it passes the x is at 90, and then it dips at 180. So now that peak, when reflected, would come here, okay, and then now the plus 45 means the graph has moved to the left. So that peak is, well, it's no longer a peak, but that upside down peak is now here somewhere. So the lowest point we're going to get in this interval is over here, on its way to the actual low point of this graph. So we need to figure out, okay, what is the y-intercept of the graph. So let's do that. So we're going to figure out what is g of 0. So that is minus cos 0 plus 45. So that is minus cos 45. And from our knowledge of special angles, it is that. So therefore, in the, let's not write it in full words. For x in this interval, the range of the graph is gonna be from negative root 2 to included, and then the highest value of the function will be 1 included as well. Okay, maybe let's just check how we're doing so far. So far, so good. Right, on to the next question. So looking at the same graphs, determine the values of x in the same interval for which f of x times g of x is greater than 0. So when the output of function f and the output of function g multiplied together is going to be positive. So as usual with these kinds of questions, we look at two cases, right? So the one way that this could happen is if f of x is positive and g of x is also positive, right? So that's the one case we consider. And then the second case would be the one where f of x is negative and g of x is also negative. Okay, so let's start with number Ian. So I mean, with these questions, I like to kind of use one of the graphs as my fixed point. I guess it's easy enough to use either one in this case. The sine wave just looks nice and symmetric, so I'm gravitating towards it. So okay, we know that f of x, there we go. Okay, so as we pause to deal with the rise, set another timer for the rise. Okay, so where is f of x positive? It is positive over here. You know, there's a problem on dark mode. There is a problem on dark mode. Do I need to make... What's going on? Oh, interesting. But now I can't appreciate it because on dark mode or on a dark page, the highlighter doesn't seem to work too well. It's a pity. It's a spitty. Yeah, none of them work well. Oh boy. So on the actual paper it's fine, but somehow on the picture it doesn't work. Very well. The price we pay for greatness. I'll just use the pencil. It's not a biggie. Okay, so that is where f of x is positive, right? That's where, so for any x value between 0 and 90, f of x produces a positive value. And then we're interested in, okay, in that same interval from 0 to 90, where is g of x positive? And that is happening over here, right? So this is in this little interval. That is where g of x is also then giving us positive values. So in other words, if we choose an x that is between 45 and 90, and I'll get to the brackets just now, then I'm going to end up in a situation where g gives me a positive value and f gives me a positive value. So when I times them together, I do indeed get something greater than 0. Okay, if I picked something between here, then I'd have a negative and a positive being times together, not positive. Okay, and then now the question of whether to include or not. So do we include the 45? Well, when x is equal to 45, f does give me a positive value, but g is equal to 0 exactly. So then the product of the two would be 0. And we do not want the product to be equal to 0. We want it to be strictly greater than 0. So we are not including 45. And for a similar reason, we're not going to include 90, because as much as g of 90 is some positive number, f of 90 is 0. So then the product will be 0. So we exclude both boundaries. Okay, so now on to the second case, the case where f of x is smaller than 0 and g of x is smaller than 0. So first we're going to look at, okay, where is f of x smaller than 0? And that is happening over here for any x value between 90 and 180. We have f of x being smaller than 0. Okay, and then the question is, in that interval, where is g of x smaller than 0 as well? And if we look, for all these x values, our g of x is just producing positive values. So this case doesn't work. So as a result, this is the only interval within this interval, the 0 to 180 interval. These are the only x values that will satisfy this inequality. Okay, double check with the memo. Yep, awesome. All right, and then the next question asks us, determine the values of x in this interval, so x between 0 and 180, for which f of x plus 1 is greater than, or I mean not greater than, smaller than or equal to 0, so negative or 0. So f of x is the sine graph, and we want to know, so there's a couple of ways that we can think about it. So the first way we can think about it is, okay, the equivalent inequality that we're solving is for which values of x is f smaller than or equal to negative 1. So then, you know, we can draw our little line there. Oh, and then they give us one of the points. Nice, that's very sweet. Right, so we can draw a little line there and say, okay, f of x is smaller than or equal to negative 1 in this little interval here, right? And we know that, okay, the interval starts at 105. Not sure where it ends, but anyway, we'll get to that. So that's one way to solve it. Another way that we can think about it is, okay, if we take the f of x and we lift it by 1, right? If we translate it by 1 unit, then the question is, in the resulting function, which part of it lies below the x-axis? So it's pretty much the same as this approach, you know, it's just this would be the x-axis in that scenario. Anyway, okay, so let's see. This is 105, and I'm inclined to think that this is helpful for us to find this one somehow, somewhere over the rainbow. I would be inclined to say that because oopsie, no. Oh my god, go away, ruler. So this is a line of symmetry for this little piece over here. Oh guys, for this little piece here, this is the halfway, right? So pretty much as with parabolas, because this is a 30-degree difference, right, from 105 to 135, then this should also be a 30-degree difference. So this is gonna be the point 135 plus 30, which is 165. And of course we can double check that on our calculators. So 2 sine 2 times 165 does in fact give me -1. Okay, so then we know that, okay, when x is between 105 and 165, this is where we have this little piece of the graph where f is just producing values that are smaller than -1. So so anything from 105 to 165, and then the question again, do we include the boundaries or not? And we do, because at 105 and at 165 the function gives us exactly -1, and we are interested in the places where f of x is smaller than or equal to -1, so both the boundaries pass. So the memo is also in agreement. You know what, I'm not so upset with this question anymore. Right, another graph P is defined as P of x is equal to minus f of x. So that's a reflection of f in the x-axis. So pretty much summon like that. No, so bad, so bad. And then we're told that D, some point D with x coordinate k and y coordinate -1 lies on P. So it's either this point or this point. determine the values of k in the interval x. Oh, battery, hang in there. The values of k in the interval x is from 0 to 180, really. Right, and again, I feel like this is a situation where we can leverage the fact that we know this guy. I don't know. Anyway, let's see. So we know that, okay, p of x is equal to minus 2 sine 2x, right? And we are looking for the places where minus 2 sine 2x is equal to minus 1, or sine 2x is equal to minus 1 over minus 2, which is a half. Right, so then our ref angle would be inverse of sine of a half, which is 30 degrees. So then yeah, because we're dealing with sine 2x being a positive number, then either the 2x is equal to 30 plus k 360, or the 2x is equal to 180 minus 30 plus k 360, and k is some integer. So x is then equal to 15 degrees plus k 180, or x is equal to 180 minus 30 is 158 divided by 2 is 75 plus k 180, right? And so the question says, what are the values of k? So yeah, because we're specifically dealing with the interval 0 to 180, that means that in this first solution, x is 15 or x is 75 in the second solution. Yeah, it wasn't an awful lot of marks, so I don't know if we needed all that heavy lifting, but okay. Right, last question. Graph H is obtained when G is translated 45 degrees to the left, so even more to the left. So it's going to be relative to the original cos graph. It's now been translated 90 degrees. Right, determine the equation of H. Write your answer in its simplest form. So that will be g of x, no man, not g of x, the new one is now h of x is equal to minus cos x plus 45 plus another 45. Okay, so that will be minus cos x plus 90, and we know that cos of 90 plus x is the same as negative sine x. So this is potentially, I think, the simplest way to express the function. And that kind of makes sense, because if you take this graph, would have been nice to carry it on a little bit so that I can snatch it. Okay, and you move it another 45 degrees to the left, so then that little hump goes to 90. Oh, such a bad redraw. But yeah, it ends up looking like that, right? Where you have your hump at 90, it's crossing the x-axis at 0 and then crossing it again at 180. It looks like the beginning of your y is equal to sine x graph. So yeah, yep, the memo is in agreement. Okay, trig graph question. I officially retract my bad vibes towards you, but at the same time, when I go question hunting again, I think I'm just gonna avoid trig graph questions for like the next few papers, because I can't. Bye.